Okay, here's video number 2, the second example, to help you with your written assignment number 10. So in this example, we're going to sketch the graph of y equals 1 minus 3 times sine of 2x plus pi from x equals negative pi to x equals positive 3 pi over 2. So this may not be one cycle, but we're going to start by sketching one cycle. And first we're going to gather all the information we need to sketch an accurate cycle and label everything appropriately. So first of all, we have to find the amplitude, and that's always the absolute value of the number that the sine or cosine is being multiplied by. So here, it's just the -3, the absolute value of -3. We can ignore that 1 that's before that. So the amplitude here is just 3. Now, the next thing we want to do is figure out what the range is, because we see that we do have a vertical translation. That 1 there that's being added to everything means that everything is going to be shifted up 1 unit. So we're adding 1 to all the y coordinates of the -3 times sine of whatever. So the range is changed partly because of the amplitude is changed, and also partly because of the vertical shift. There's 2 things going on that change the range. So first of all, because we have an amplitude that's bigger than 1, the amplitude here is 3, we know that changes the range. We know the y coordinates, when you multiply the sine function or the cosine function by a 3 or a -3, the y coordinates are all going to go up as far as +3 and down as low as -3. So that means the range would be changed, and it becomes -3 to +3. And we've been doing that. That's how we label our y-axis. But in this one, we're also shifting everything up by 1. So we're taking this interval, -3 to +3, and we're adding +1 to all of those numbers in that interval. So shifting the graph up 1 unit shifts our entire range up 1 unit. So we can add 1 to these 2 numbers. So -3 plus 1 up to -3 up to +3 plus 1. So our new range goes from -2 up to +4. That's the new range. And so that's what we're gonna use to label our y-axis. All right. So now we need to find the interval for one cycle, the interval that the x values go between. So one cycle, to get the cycle, we're going to start with one cycle of the regular sine graph, and that cycle goes from 0 to 2 pi. So we're going to take our argument, 2x plus pi, our new argument, and we're going to put it inside that interval from 0 to 2 pi. So we set up the inequality, and then we solve this for x. So let's first subtract pi from, you got to subtract it from everybody. So we're left with negative pi is less than or equal to 2x is less than or equal to positive pi. Now all we have to do is divide by 2. So we do that everywhere. And we get cancellation there. And we're left with a new inequality. Negative pi over 2 is less than x is less than pi over 2. So this is our new interval. This is the cycle we were looking for. The new interval in interval notation is going to be this, negative pi over 2, comma, pi over 2. We have square brackets at both ends because we're including those two numbers. All right. This interval also gives us the period. So the period is going to be pi over 2 minus negative pi over 2. And that is just pi over 2 plus pi over 2, which is pi. So our new period is pi. So now we're going to start labeling the axes with the information we've gathered, and we're just going to start with one cycle. So we're just going to go from negative pi over 2 to positive pi over 2, and we're going to go, remember, we're going to go up to positive 4 and down as low as negative 2. The new range is negative 2 to positive 4. Now, the other thing, we're going to divide up our interval on our x-axis. So we need 5 key points in total. So negative pi over 2 and positive pi over 2 are the first two, and then we needed the 3 in between. So those are negative pi over 4, 0, and positive pi over 4. Now, before we start graphing, we need to know where that midline is, because we had a vertical shift. We know we're shifting everything up. So where's that midline? Well, it's halfway between our highest point and our lowest point. So you could either do it graphically or do it arithmetically. And so I'm doing it arithmetically. I want to get the midpoint. So I go 4 plus negative 2 divided by 2. I just find the average of the highest and lowest number. So 4 plus negative 2 is positive 2, and positive 2 divided by positive 2 is 1. So 1 is halfway between negative 2 and positive 4. So that's where our midline is going to be. So it's right about there. And I'm labeling it with positive, y equals positive 1. My positive 1 looks almost like a 4, so I'm going to redraw. There it is. Okay. So now, that's where, that's going to act kind of like our x-axis, right? Because we're just shifting the x-axis up by 1. So when we plot our points, we know where to put down those points that would have gone through the x-axis, would have been on the x-axis. Sorry. All right, so we're ready to start plotting our 5 key points. This is a sine graph, so we remember that the first key point of a regular sine graph is sitting right on the x-axis. The height is 0. It's right on the x-axis. And then the last one is also on the x-axis. But this is a new transformation. It's been shifted up. So we're going to put that first key point on the midline. And the last one goes on that midline too. And remember, the middle one does as well. So the first 3 key points are sitting right on that midline. Now, the second key point, the one that we will draw at x equals negative pi over 4, that one is either going to be up at our highest y-coordinate, positive 4, or down at our lowest y-coordinate, negative 1. And we make the decision based on whether or not there is a minus sign in front of the sine function. So when we look at the equation, y equals 1 minus 3 sine of all that other stuff, we go, okay, it does have a minus sign. So that means it's been reflected. So that means we're actually going down from our first key point to our second key point. So our second key point is down at our lowest y coordinate. So it's down at negative 2. And then the last key point that we plot, the one at positive pi over 4, that's going to be up at our highest y coordinate. So there's the 5 key points in one cycle, so we can connect those dots. So now we're not quite finished. So our original task was to sketch the graph from x equals negative pi to x equals positive 3 pi over 2. So we have a little more work to do. So let's label on our x-axis. We're going to go down as far as negative pi and up as far as 3 pi over 2. So there's a few more points. So now at negative pi, so our period was pi, right? So looks like my graph is still on the left, still got to go up a little bit. There's going to be a high point that I have to get to, and that's going to be at negative 3 pi over 4. Halfway between negative pi over 2 and negative pi is negative 3 pi over 4, and that's where my it's going to reach the highest point up there, and then it's going to come back down to the midline at negative pi, so there's a point there, so I can connect those two dots. So I've just extended it down in the negative direction, but now I have to go in the positive direction, and that's going to be a little bit more of a graph. So it looks like my graph on the right is still going to go down. I have to get to a lowest key point, or a lowest point halfway between pi over 2 and pi, which is 3 pi over 4. So there's a lowest point down there. Then it's going to come back up. It's going to have to go through the midpoint, or the midline, sorry. And it's going to go through the midline when x is pi. Then it's going to reach its highest point at x equals 3 pi over 2. So now we can connect those dots. And we've extended it on the right. So that is one of our most complicated graphs that we've done. And you have a similar one in your homework, but it's using a cosine, a transformation of a cosine. Notice how many transformations we had in this graph. We had a vertical translation, a horizontal translation. We had a reflection, that negative sign, that minus sign gave us a reflection. We also had a vertical stretch by 3, that amplitude got stretched, and we had a horizontal stretch. So there was a lot going on here. All right, there will be one final video to help you with that assignment.